to be equals to x squared minus 3x. And we are told to find dy dx. Most of us are scared of calculus, but you don't have to be scared of anything, okay? So what is dy dx? We have dy dx. Okay, dy dx is equals to, what we are going to do, decrease the powers of x by 1. Okay, then use the initial power to multiply this. So let's write down these 2. Okay, write down these 2. Then write x. Then subtract 1 from 2. Decrease 2 by 1. Okay, that is 1. It becomes 1 here. Although there's no need writing the 1, right? So we are going to clean the 1 here. Then minus. This is 3. And don't forget, here we have 1. 1 minus 1 is 0. And x raised by 0 is 1. So 3 times 1 is 3. This is exactly how to solve this. This is the simplest method, okay, and it's the shortest and the quickest method for solving differentiation. I hope it is well understood. Now let's quickly go to the next page. All right, we have another question right here with us. So I hope you are with us. So thank you very much for joining. I wish you all the best in your exam. For those who are writing JAMB today, I wish them the best. Thank you very much. And you that are writing tomorrow and so on, I also wish you the best. So we are going to be moving into the next question without wasting much time. So in this case, the question usually comes in the form of if, or derivative. Okay, if y is equals to the square root of x. Okay, if y is equals to the square root of x, find dy dx. Find dy dx. So this is what we are going to do. If y is equals to the square root of x, then what is dy dx? This kind of question shouldn't take more than 5 seconds, right? Shouldn't take more than 5 seconds. So let's look at the solution to this question. We are given y to be equals to the square root. We are given y to be equals to the square root of x. So the implication is that we are going to transform this to indices. Okay, this is not in index form, so we'll change it to index form for better visual understanding. This is x now, right? This becomes x here. This square root means raised to power half. This is raised to power half. Okay, so since it's raised to power half, we can go ahead and find dy dx. So what is dy dx? Dy dx is equals to, bring down this power here. This is half, so bring in half here. Okay, bring in the half here. Then here subtract 1. Okay, so we have times x raised to power half minus 1. Okay, you can use half minus 1. So what does it mean? This is going to be 2 times 1. Okay, don't find LCM in this kind of question or in a place like this. Okay, just multiply 2 by 1. That gives 2 divided by 2. Okay, 1 minus 2 is minus 1 divided by 2. So this is what we are going to have here, minus 1 over 2. Okay, that is what it is. So I do hope it is well understood. This has solved itself. So this is the question number 2 and the solution. All right, so if you have any question, let us know in the chat area. Okay, there's no special place for chatting. Just write hash question, hash answers. If you have suggestions, just put hash and give a suggestion. Okay, yes, this is exactly the question number 2 for today. We are quickly going to go to the next one, the next question, without wasting much time, right? So wishing JAMB candidates that are writing today excellent results. Yes, excellent. They will not forget whatever they have worked for. Yes, so let's move to the next one. Yes, almost the same thing here. If y if y is equals to x raised to power minus half. This is minus half, okay? Then what is dy dx? Find dy dx. Yes, find dy dx. What's going to be dy dx if y is equals to x raised to power minus half? So just the addition of negative. There is an inclusion of negative sign here. The one we just finished now has no negative sign, it's plus here, but now it is negative. So this is what we are going to do. We are already giving y to be equals to x raised to power minus half, right? Then what do we do in this case? Remember, it's the same principle. There is nothing different here. Okay, what we are going to do right now is to simply subtract half from here. Bring this minus half here. So we are going to have minus 1 over 2. Then rewrite this x, but as for the exponent, decrease it by 1. So subtract 1. We already have minus 1 over 2 here, minus 1. Okay? Then 2 times 1, that becomes, this is minus, so that becomes minus 1 here. All right? Then minus 2 times 1 is 2. Then divided by the only number at the denominator. So minus 1 minus 2 is minus 3. Then we have 2 at the denominator. This 2 gives us minus 3. So this is what we are going to have here. Minus 3 over 2. Yes, you can leave it like this. Most times in JAMB, you just leave it like this. But in WAEC and NECO, our class will soon commence in WAEC and NECO, okay? But right now it's JAMB. So, but right now it's JAMB, okay? What it means is, this is the final answer. But there are other ways to express it, which we are not going to bother ourselves about now. So let's leave it at this end. I hope it is well understood. If you are with me, then just tell us in the chat box, okay? Type I am with you. I want to see your chat, right? Because it's very important we work together. Any question? Should we move ahead? You see, this is a request from one of our viewers. I think just yesterday also. Yes, and 3 days ago, someone requested that we start working with calculus. So that's why we are looking at calculus today and tomorrow. Okay, so if you have any difficult topics, why not let us know from the chat box? I want to know. Okay, if you have any difficult topic that's giving you headache, just let us know. Don't be shy to let us know, because it's very important. Okay, because your presence is what makes the difference. Okay, so let's quickly take the next one without wasting much time. This is the third question for today, not question 1, but the third question for today. So we quickly go to this. Look at this. We are told to find the derivative. Okay, find the derivative of this kind of question. Just look at it. Find the derivative. Find the derivative of y equals, okay, of 2x open brackets x squared plus 3. Yes, we have to find the derivative. Well, the question may come in the form of derivative or differential coefficient, okay, or dy dx. Yes, sometimes you may be told to find dx dy, which means you find the dy dx, then invert it. That becomes dx dy. Okay, so it can come in different forms. JAMB can be very tricky, so you need to understand them very well, okay, if you want to do extremely well. So we are giving 2x here, x squared plus 3. There's no need. Some person will say, let's use product rule. We don't need any product rule. There is no 10 here. We don't have numbers like 10 here. We don't have large numbers or fractions. We don't have fractions here. Okay, so we cannot be burdening ourselves and wasting our time using any of those rules, quotient rules, this rule, product rule. No, just come here, write y equals to this. That's what it means. It means that y is equals to 2x open bracket s squared plus 3. Now, what is dy dx? Derivative means what? This word derivative means dy dx. So we are going to make dy dx like this, and that is equals to what we are simply going to do first before we go into dy dx. Multiply out, clear the brackets. Let's clear the bracket. 2x times x squared is 2x raised to power 3. Because this is 1 here. 1 plus 2 is 3. Okay? Then plus. Then 2x times 3. 2 times 3 is 6. So that's 6x. We're going to have 6x here. That's what we have. Then we can go ahead and differentiate this. Differentiating it, bring 3 here. We now have 2 dot 3, okay, then dot x. Then subtract 1 from 3, that gives 2 as the exponent on x. Then plus. When you differentiate just a letter like x with respect to this, you have only 6 left. Because this is 1, this was 1 here, right? Then minus 1. 1 minus 1 is what? Is 0. And x raised to 0 is 1. 1 times 6 is 6. Right? That's what it means. So we don't need to bother ourselves. Then we can go ahead and multiply. 2 times 3 is 6. And that is 6x squared plus 6. Okay? If you wish, or you may go ahead and factorize. We can see that 6 is common. So since 6 is common, bring out 6. Okay, bring this 6 outside. Then divide by 6 here. We have only x squared left. Then plus. Divide by 6 here. We have 1 left here. So any of them is okay. This, or this. They are just the different stages of simplification and differentiation. Right? So from here to here is differentiation. But here downward is just simplification. Right? So any question? Okay, if we are following, let me know in the chat area. I want to know, we want to be sure, okay? Because AZ Science TV is committed to ensuring that every student passes his or her exam without any form of obstacles, all right? We take out all forms of obstacles so that it becomes easier for you to pass your examination. Now we are moving to the next one. Let me proceed because we are going to continue. All these are questions that are likely to come out. We are not saying that it will be repeated, but it will pattern this format. Okay, the question will come in this format. That is how JAMB does it. JAMB does not change its pattern. Sometimes I have shown you in my previous live streams where they repeated questions. I remember, right? I showed us how they repeated some questions, but not always. So don't depend on that. Okay. If this is another question, if y is equals to 4x raised to power 3. If y is equals to 4x raised to power 3 minus 12x squared minus 12x squared plus 3x plus 12. Okay, if this is equals to this, then find dy dx. It's just the same thing. Okay, find dy dx. Yes. Who can help us do this now? Yes, I know that someone can be bold to do this, right? So let me see it in the chat area. Okay, who can help us? Who can solve this for us? Who can solve it even before I finish it? All right? We are already giving our y to be 4. X raised to power 3 minus 12. Okay, 12x squared. 12x squared plus 3x, then plus 12. So we are to find dy dx. Look at it here. Okay, what is dy dx? Most students are scared of calculus, but it's the easiest mathematics. Okay, it's the easiest part of mathematics when you actually look at it very well. You see that we have not done any serious job. In fact, you don't need calculator in calculus. Okay, calculus itself will calculate itself. All right, so there's no calculator here at all. So 3 times 4, these are just small numbers. Okay, who can tell us the answers? I just want to know in the chat area. Yes, who can tell us the answers? Let's see. Okay. Yes, okay. Thank you very much. Sir, oh my God, thank you, thank you. You so smart. No, thank you very much. Is it Shiny? Okay, okay. Thank you. I appreciate all of you. Okay, Jeremy, Samuel, thank you. Okay, then Shriyansh. Oh, thank you. The name is very. And then local guy. Wow, that's great. Your names are very powerful. Okay, you guys are wonderful. Thank you very much. I see all your chats. Okay, I appreciate all of you. You're such wonderful people. Thank you. So this is the YDX. Okay, dy dx. If you're writing JAMB, just drop it in the chat box, okay? So that I tell you, I have a lot of tips for you by the end of this class. So, okay, just let us know. So we go for dy dx, dy dx. dy dx will be 12. That is, this is 3 times 2, okay? This is already 4 here, so times it by 3. Bring down this one, 3 times 4 or 4 times 3. It doesn't matter. Then this is x raised to power. We are going to decrease the 3 by 1. That becomes 2 here, right? Then right here we have our minus still left here. Nothing is changing it. We have 12.2. This 2 will come down to multiply the 12 here. Then this one, the x will vanish, right? X will vanish because x is the same thing. X is the same as 1. That is in this case. All right. So we are, that is in this case. All right. So we are left with only 3 because 1 times 3 will be 3 here. Then this will disappear. It becomes 0. I'm sure we understood why it will disappear. Yes, we'll prove it in our next class, but I don't think JAMB will be interested in that for now. Of course, they can, but it's good you know it. Nothing is impossible. Everything is possible, okay? Especially for JAMB students. Now we proceed. 4 times 3 is simply 12 x squared. Okay, 4 times 3 is 12 times x squared. Then minus 12 times 2 is 24. This is 24x plus 3. This is the simple, this is called differentiation of algebraic functions. Okay, not trigonometry. So we'll handle trigonometry later, but we are looking at the simple differentiation of algebraic functions. So after that, this is the first segment. We are not dealing with first principle because you don't need that in JAMB. It wastes a lot of time. Okay, we don't need it at all. So we move to the next one. Then let's look at the ones that have powers. I do hope you understood this. You just follow it gradually. Okay, this 3 times 4, bring the 3 down, then decrease it by 1 here. Bring this 2 down and decrease it by 1. Okay, right here. Then this 3, okay, decrease this 1 by 1. It's like bringing 1 down is still 1, so there's no need for that. All right, then decrease the 1 by 1. That's 0. So x raised by 0 is 1. 1 times 3 is 3. So that's how we got this. When this is simplified, we get this directly. Okay, so thank you. We move straight to the next question without wasting much time. Welcome for those of you who are viewing. I hope you are subscribing. Oh, subscribers, please. I want viewers to subscribe. Okay, do well to smash the subscribe button. All right, so you can get more benefits. There's a lot of tips coming. All right, not just in this class, but subsequently. Even those that prepare for WAEC and NECO, those that are writing practicals too, do well to smash the subscribe button. Okay, maths, physics, anything. Okay, whether you are arts, social science, or business. Okay, don't worry, just smash the subscribe button. Okay, the channel is for everybody. Here we have if y is equals to 1 plus x squared, find dy dx. Find dy dx. I don't know, can you see from here? I'm just being very careful so that I don't write what you cannot see. Okay, let me write it here. Find dy dx. Okay, this is what we have for the next question. You can see that here we have an exponent, right? Yes, it's like a binomial kind of expression. Yes, this is a binomial expression. So you can use binomial theory to expand it. Or let's go ahead. There are different methods to deal with this. All right, I will teach you the simplest method now. So let's look at the solution so that you don't waste time in JAMB or when it's time for you, the day of your exam, okay, whichever day. So I think somebody said Friday yesterday. So depends on you, depends on your registration date. This is y equals to 1 plus x equals to 2, right? Now, the shortest way, some persons will expand before differentiate, but there's no need for that. Okay, differentiate what is inside. Differentiate 1 is 0. Differentiate x is 1. That is 1 dot. Okay, 1 dot. Then differentiate this one, what you are going to do, differentiate like normal thing. Okay, differentiate like is normal. Like if you differentiate x square, remember it to be 2x. Okay, differentiate this to be 2x. You get it? So differentiate this one like 2x. Okay, it will now be 2 open brackets 1 plus x. Decrease this one by 1. You see, you brought this 2 here, just like you brought this 2 here to give us this, right? I hope I'm not doing the wrong thing. This is y. If y is this, what is dy? Dy dx will give us 2x. Okay, so what is now dy dx here? Dy dx is 1 dot this. So this is what we get as our answer. Go ahead and find and expand. Okay, if we expand it out, what do we get? This is 2. Don't forget, this is 2 open brackets 1 plus x. Don't forget. So this is the simplest way. Some persons will use chain rule. Some will use chain rule. Yes, chain rule, substitution method, but it's not necessary. Just understand how to do it. This is exactly how to do it. If you like, you can go ahead and open the bracket, but it's not necessary. This is the solution to this particular one. Why? Simply because if you differentiate what is inside here, you get 1. Then times differentiate the whole as if it is x squared. Where you differentiate x squared, for example, if y is equals to x squared, take this one like x squared. Then bring these 2 down here. Okay? Just like you bring these 2 down here. Then decrease, multiply it by this. Okay, multiply it by what you have here. Decrease this one by 1. 2x is by 1 because you have removed 1 from here. So remove 1 from here. That was what we just did here. So first differentiate what is inside here. Keep it here. Times, multiply by this power. Okay, then bring everything here and subtract 1 from the exponent. So that gives us this. Then at the end of the day, we'll get something like this. All right, that's exactly how to do it. I will show you how to do the sign as well. Okay, the sign, because some person may not know how to do the sign function. The sign function. So let's look at this. We still have more. I want to show you more so that you will have more experience. Okay, with more examples, you'll be getting better understanding. We are now in the powers. Don't forget, we are done with the ordinary one. We have entered segment 2 where we have powers here, and you don't have to expand. If you wish to, no problem, but you don't have to. Okay, I hope it is well understood. Let me know in the chat box. Okay, if you are just joining me, let us know. Okay, whatever you have to say, let's know. Okay. Oh, Godfrey Sunday. Yes, you were here yesterday. Godfrey was here. Mr. Godfrey, thank you. Thank you. Yes. Okay, I'm seeing so many. Oh, thank you. Local guy. Your brain is very hot. Local guy, take it easy. Where are you running to? See calculation. Yes, he got it right. Thumbs up. Thank you, local guy. Thank you very much. I appreciate you. Your presence here is making a difference. And all the viewers, we are very grateful. AZ Science TV says thank you to all of you for always being here. So, those of you that are hungry for success, you will definitely get that success. Let's move straight to the next question without wasting much time. In fact, we don't have time to waste because JAMB is hot right now. Yes, Everybody's head is hot. Now, look at this particular one, because some of us don't know. I will come back to standard integral, but before then, look at another way the question can be set. Given that y is equals to, open bracket, x plus 2 square, like this. Find dy dx. Find dy dx. Let me show you, let me tell you something. JAMB does not set question that is difficult, but the question is just tricky, just question to test, okay, test us if we are very smart. That's what JAMB is doing. Not that they will go and set question that is very complex, like why can never know. Okay, now let's look at this. We have y equals to x plus 2, then raised by 2. Yes, we are to find the dy dx. As in differentiate, that's the meaning. Okay, differentiate it with respect to what we have here. If it's theta that is here, to be dy d theta, but this is x, so dy dx with respect to x. So who can give us the solution to this? Yes, it's very simple. I've done this one. I just finished the previous examples. It was just like this, previous examples. So what you are going to do, there is nothing attached to it. No x here, nothing again. So it's just like, look at, solve this one like this. Let me show you something. Solve it like this. First, differentiate what is inside. If you differentiate this x, you get 1. Okay, you get 1 dot. Because if you differentiate 0, you get, if you differentiate 2, it becomes 0. 2 will disappear, right? Then open bracket, differentiate this, the whole of them, this whole expression, as if it is x squared. You understand? As if it's x squared. So what is dy dx here? Dy dx. Bring these 2 down here. That is 2, right? So bring it here. Do the same thing. That is 2. Bring these 2 down this way. It becomes 2. Remember, we are done with 1 inside, which gave us 1 dot. Bring these 2 here. Okay? Then that gives us what? 2. 2. Then what is here? We have x. Decrease this 1 by 1. Decrease 2 by 1. It becomes 1 here. Do the same here. Open bracket. Bring everything inside as if it's an algebraic term. Okay? Then this one is 2 minus 1, which is now 1. So you have decreased this one by 1, just like decrease this one by 1. So we can go ahead and evaluate it, right? So can you tell us what the answer will be? If this is very easy, don't use chain rule. Most persons will use product rule, chain rule. No, sometimes these things can be very confusing, or it takes time. You know it, yes, but it will take time. That's a challenge. A lot of students fail mathematics and other calculation subjects like physics and others because they can't manage their time. They are looking for the short method. That's why we are using the tricks. I know you know the long method, but right now we are using the short method. So 1 times 2 is 2. Okay, open bracket, x plus 2. We can open the bracket if we wish, but it's not necessary, except if the question demands that we open the brackets. But factored method is better. Okay, the factored end is better. So any question? Are you with me? I hope we are following. I wish you excellence in everything you do. Yes, especially in this season of JAMB. Any student writing WAEC, NECO, JAMB is going to blast his or her exam. Okay, just make sure you are following the tricks we are showing you, and also remember to pray and work hard, and you see yourself excelling. So I wish you all the best. Now we move to the next phase. Now remember, we just finished the one that have whole number powers, right? Now let's look at a bracket that has fractions, like half, minus half, you know, all of that. So that's what we want to do right now. We proceed to the next question. So let's quickly take the next question. Look at this question. If, yes, sometimes it comes in, if y is equals to, open bracket, 4x plus 3 is per half. It's per half, okay? Something like this. It's per half comma, find dy dx. Find dy dx. So this is another way the question can come. Okay, this is another form you can get your question. So if you get a question like this by tomorrow or whichever day you are going to write the exam, if you find something like this, don't worry. Okay, use the method I'm about to use now. Okay, this is 4x. It is 4x, then plus 3 raised by half. Yes, this is what we have. Then we are looking for dy dx. Don't forget that. That's what we have to find here, dy dx. So what is dy dx? dy dx is equals to, start from here, differentiate what is inside here. You differentiate 4x. Remember, when you differentiate 4x, x will disappear, leaving us with only 4. And when you differentiate 3, becomes 0. So we'll be left with only 4 here. You bring the 4 outside. Then we want to differentiate the whole of this one. Remember, when you differentiate x, let's say when you have x raised by half, bring this one down here, okay, to get the dy dx. Bring this one down, it becomes half. Then x raised by, this becomes half minus 1. Okay, half minus 1. So minus 1 from half, we are going to get minus half. You get it? So this is what we are going to get. We're going to get minus half. Yes, because the half comes down. Because 1 is greater than half, right? 1 is greater than half. It's like having half like this minus 1. 2 times 1. Don't look for LCM. So this becomes 1 minus 2 times 1 is 2. Divided by the 2 underneath it. 1 minus 2 is minus 1 divided by 2. So this is what we are going to put here. So which means you are multiplying by half, dot half. Please, dot means multiplication. It's not decimal, okay? It's multiplication. I would have liked to just use multiplication for those who have not been doing differentiation. So then we can open our bracket, bring in this one. This x is now represented by the whole of this bracket. So that is for x plus 3. Okay, remember, half has become minus half because we subtracted 1 from here. It becomes minus half. You see it? So that's how it will be. It can be like this, or it can be in another form. Let us express it in that other form, because this is very important. If it comes in that form, you should be able to answer. Please, second, please. So what it means is this. This is 4. Half of 4. These 2, we cancel this 4, right? Yes, so to divide this 4 becomes just 2. Okay. Yes. Then this is minus half, right? Minus half. So this becomes 2 divided by what? Because this one is 2. It will be on top here. This is minus half. So that gives 4x plus 3. It may stop here, but I think it's better we'll do it this way. And raised by half. So what happens? The minus has disappeared. What does half means in indices? In indices, when you have x raised by half, it actually means the square root of what? X. This is what it means in indices. Please don't forget. Okay, x raised by half is square root of half. So we can do that here. Okay, finally, we'll have 2 divided by the square root of 4x plus 3. Okay, this is the answer to this question. It's not difficult. You just have to follow it that way. You know that you can actually skip all these things if you understand it very well. If you are very smart, of which you are true. I know you are very, very smart. So since you are smart, what you do, learn to skip these ones that takes most of the time. Okay, just look at this trick. The next question will come in any one of the methods we have used. Okay, what you do is to try as much as possible to skip some of these middle terms. All right, yeah, so that you can move faster and get your answers. From the answer, you can even tell which one is coming from here and which one is not coming from here. So that is just for that. Thank you very much for joining me. AZ Science TV, I appreciate you. Please do well to smash the subscribe button. Yes. I forgot to say that, please, okay, because more powerful tutorials will be coming to assist those that are writing WAEC, NECO, and even those that are still writing JAMB. We have a lot of shortcuts, tricks, and tips, okay, as well as a lot of things we are going to tell you that will quicken your examination, okay, and make you better. Thank you very much. So let's proceed to the next question without wasting much time. Yes. Permit me to clean this and move to the next one. Okay, now we are going to take this particular one. Okay, I think I should have gone further, but okay, yes, I have one here. One is a whole number, but such a large number. If y is equals to 3 plus 2x squared all raised to power 10. They say we should find dy dx. Find dy dx. Please subscribe, okay? If you are joining me for the first time and you're not subscribed, please do it. Just subscribe. Yes, subscribe. Yes, look at this. What is the solution? What do you make of this? Yes, put the answer in the chat area. Let me see from you. We have y equals to 3 plus 2s squared, okay, something like this. So what is dy dx? What is dy dx? That's what we are talking about here, okay? Please, someone should do this for us and put it here, okay? I'm more than happy, and I'll give thumbs up for doing this. Just try it. It's not difficult, okay? Very, very easy. Just use the previous method and solve it. Start from here, then differentiate this one like s squared, put together and get your final answer. You don't need to expand. The power is very, very much, okay? Raised to power 10 is not a small exponent. It's such a great exponent, okay? Oh, yes, I can see some persons working out this strategy. Yes, you are correct. Yes, it's correct. Very, very correct. Thank you very much. Who did this? Oh, that is another person. Please, your letters are such wonderful letters. I can't pronounce your name, but I know you did extremely well. I saw your work. It was very nice. Now, what is dy dx here? This is easy, okay? Always start from the inside. Don't start from the outside. Start from the nucleus. Start from the inside. So let's differentiate now. If we differentiate 3, what happens? 0, right? Good. This is 0 when differentiated. Then what about this? We have 2 dots. Then this 2, we come and join it again as 2 times 2 here. Okay, 2 times 2. Then we have x right here. Okay, that's what we have now. Then dot. Bring everything again. Look at it. 3 plus 2x squared. You see that? Differentiate it as if you are differentiating x raised to power 10. Something like this, x exponent 10. Okay, bring 10 here. Okay, bring 10 right here. So dy dx will now be what? 10 x raised to power or x exponent 9. This is what we are going to have here. So which means we are going to have something like this. Bring down this 10. Let me show you so I don't waste much time. This 10, bring it here. That is 10. Then before opening brackets, bring everything. Everything here represents x. It looks like x, okay? So that becomes 3 plus 2x squared. Then this is 9. So decrease here by 9. By 1, sorry. Decrease this by 1. This becomes 1 here. You can see how simple it is, right? Then the next space is just simplification. We have done the differentiation. So how do we simplify this whole expression? This is 2 times 2 times 10. 2 times 2 is 4. And 4 times 10 is actually 40. So we are going to write 40 here. Then we have our x. Don't forget anything, okay? Can lead to error. And that is dangerous. But thank God for JAMB because the options are there. We can easily find our way. that is x squared, right? Is 9. So this is the solution to this question. It is very, very easy. Okay, just follow the procedure. Start from the inside. Differentiate this one is 0. This is, if you differentiate this one, you get 4x. 4 because this is 2 times the 2 that will come here and multiply it. That's why we have 2 here, x. Decrease the 2 by 1. Decrease the exponent by 1. So that is 2 minus 1 is 1. So it's like having 1 here. It's like having 1 right here. Okay. Then once you are done with differentiating the inside, which gave us the whole of this one here, now it is time for us to differentiate the whole here, everything, as if it is x squared or x raised to power 10. So bring down this 10 here. Okay, bring it here. Rewrite everything. Rewrite the brackets. Then decrease the power by 1. That gives us the answer straight away. There's no problem at all. Okay, make sure you use these shortcuts when you get it tomorrow. Okay, I don't know, the chain rule or function of a function might take some time. So that's why I do want us to always bring this type, because it's very easy when we use a simple method. Now we are going for, let's do some very critical work here. I want us to look at exponential functions, okay? Or if, okay, yeah, I have one here. I have one here before we move to the other one. Let's look at this particular one. I do hope you are putting it down, or that you have already put it down. Okay, so thank you. Let's move straight to this particular one. Let me show you something here. Here we are given that if y is equals to x squared minus 1 over x, they are basically the same. Okay, and we are told to find dy dx. Find dy dx. So that's what we are told to find. We are still going to use the same method. So that you can see there's a mixture there. One is a fraction, while the other one is normal. This quadratic kind of, okay, why is just a fraction? Yes, some students will go about trying to simplify it. There is no need for that. Okay, it's even more complicated when you try to make it a single fraction. The easiest way is this. Don't use quotient rule, don't use any rule. Look at what I'm going to do here. We are going to bypass all these rules. In fact, we'll break the rules today. Yes, and move on. Okay, yes, we'll look at this. Okay, let me write everything before I show you something here. Look at what I want to show you here. Okay, this is x squared. Just write x squared. Treat them separately. This is x raised power, and sorry, this is the inverse of x. So in the law of indices, this is raised power 1, right? If we want to write it, we can write it like this, So we have transformed this one to this, from the state that it was here to this present state. Okay, it's very easy. This is going to assist you to move very quickly. So this is x squared. What is now going to be our dy dx? What will be our dy dx? Bring these two here, becomes 2, then this is x, then minus 1 from here, okay, becomes here. So we minus 1 from here. Then we are going to bring in this bracket, okay, then minus this minus 1, bring it down the way we brought 2 down here. That gives us minus 1. Okay, this minus 1 can come down. Then we have our x. Subtract 1 from minus 1. It becomes minus 1, which is minus 2. Okay? Remember, when you have minus 1 and you subtract another minus 1, you bring in minus 1 again. Okay, this is minus 1, minus 1. Okay, it becomes another minus 1 here, which is minus 2, which is minus 2. Okay, which is minus 2. It's downstairs. So I'm still busy now online, please. When I'm done.
What's it now?
No, it's not a video, it's a live stream. Okay. Okay, please. This will give us minus 2. So sorry for that conversation, please. And this one is going to be 2x1, 2x1. So this one, these two, okay, will be plus, okay, this is plus. Then this is x, this for minus 2. Remember, it's minus times minus, that is plus here. So this will be minus this. So this will now give us 2x, okay, 2x, then plus. We can revert this one back to this, right? So what is it going to give us? Give us 1 over x squared. Please, okay, I hope it is well understood, right? We just look at it very well and see, okay? Is off, right? Sorry. Sorry for that. My microphone is off. Yes. Can you hear me now, please? If you can hear me, let me know. The microphone actually was off. I have to turn it off because it was taking too long. Yes. If you can hear me, let me know. Okay, put it in the comment, in the chat box. Let me be sure. Now, this one is going to excuse us first. Okay, this is going to excuse us so that we go to the next phase. So, the solution to this, what's the solution? You can solve it and put it there in the chat box. So here we have y. We have y equals to the cosine of 4x. Y equals to the cosine of 4x. Now, this is what you are going to do, just like you did the one of x plus maybe 4x plus or 8x plus this or whatever. And always start from here, differentiate what is here and put it here. When we did that of 10 or anything, right? Or half. So first start from here. But in this case, we are starting from 4x. So what is dy dx of 4x? Differentiate it. You will get 4. Then come and use it here. Multiply it here. Then change cosine to sine. Cosine, okay, to sine. There's going to be minus, right? Minus sine. So it's going to be minus sine. Then bring in the 4x again. Close it. You have finished the work. That is the shortest way to do it. No chain rule. Okay, we have passed chain rule. We are no longer in chain rule. We are now doing the normal thing, following the shortcut. So this is minus 4, right? Yes, that's minus 4 sine 4x. Minus 4 sine 4x. Minus 4 sine 4x. So this is what we have. This is the answer to this particular question. Okay, I want you to do this for me. Okay, this one challenge. Yes, let's do this challenge and let's see. We okay? Yes. Y. Do that of y. Let's see y. Okay, let's say if y is equals to cos. Okay, let's say sine. If y is equals to sine 8x, okay, then find dy dx. So who can do this? It's a challenge for every one of us, okay? So just do it and put it in comments in the chat area. Hashtag bring in the answer, okay? So this is very simple. It's like this, but you know something will happen, right? In this case, there will be no minus. When you are transforming, there will be no minus, just like I said initially. Okay, just use this pattern and solve without wasting much time. Okay, if y equals sine 8x, find dy dx. So what should this be at the end of the day? So please, let's see in the chat box. Fastest finger. Who is going to get this now? Who is going to get it right now? Come on. Yes. We need an answer to this right now, as in emergency. So who can do it for us? Yes. Let's challenge ourselves. Let's challenge ourselves. So in this side, challenge. Yes, challenge. Who can challenge us with this? Give it a try. Okay, sometimes it's good to try something. Okay, when you try, then you get better. Okay, now let's proceed to the next phase. Look at this particular one. I have if y is equals to 2 sine 8. Let's say, okay, 2 sine half x. Find dy dx. Okay, sorry, let me bring it here. I'm skeptical about you seeing there. I don't know if you're going to see it. Find dy dx. Find dy dx. So what is dy dx? Knowing fully well that y is equals to 2 sine half x. See, this kind of question may come in in different form. Yes. So I don't know if you have gotten the answer for the challenge. Do we have the answer? I think is 8 cos 8x. Wow. Precious stars. You are a star indeed. Precious stars. Our brain is hot. Yes, you got it. It's sine to cos. So that's 8 cos x. Wow. In fact, let's clap for precious stars. Thank you very much. Okay, precious stars, you've done it well. It's correct. So the answer to this dy dx is equals to 8 cos 8x. Yes, precious stars got it. Thank you very much. Yes, precious stars. Thank you. You did so well. You got it, and I'm proud of every one of you. Okay, I'm proud of precious stars and every other viewer and all my wonderful subscribers. I hope you have subscribed. Yes, I want everybody to subscribe so that you can keep getting benefits upon benefit. It's not about money or whatever. The lesson is free. So for those who are preparing for exams, the lesson is free for all of you. So thank you very much. The challenge is over because Special Star ended it for us and gave us the solution. Dy dx is 8 cos 8x from here. All right. So precious stars. Okay. I see you there. Thank you. So let's go to the next one, which is, so right here we have y equals 2 sine half of x. This is fraction. Okay. So y equals to, don't worry, this is the same method. Okay, it's the same thing. I'm sure somebody has gotten the answer. Yes, somebody has gotten the answer because you don't have to waste time. Yes, you don't have to waste time here. So what's the answer to this? What is dy dx? Just use the same method. Please don't worry. Okay, use the same method. Differentiate this one here. Just like you got 8 or any other number we got before. And that's how we're going to get half here. So it means we already have 2 here. Bring the 2 dot. Differentiate this one. Differentiate half x. The x will disappear, leaving half behind. Then sine to cos. Sine to cosine is what? Sin cos. So sine to cosine is positive, right? Yes. So okay, it's positive. So there's no need for the brackets. That is cos. Repeat half x here. This is the simplest way. Don't forget what happens here, right? This is a numerator, this is a denominator. So they will strike each other. Okay? What it means that these 2 will cancel these 2. And that gives us only this. Because 1 times cos half x is the cosine of half of x. This is the solution to this question. And I do hope it is very, very clear. If you don't understand, let me know in the chat box. Okay? So don't forget that we'll be coming here tomorrow again. And if you're not subscribed, please, I'm still waiting for your subscription. Just subscribe, smash that button, and turn on notification. Okay? Because that is the only way you will get notified when the video starts next time, maybe tomorrow or so. Okay? So we are going to definitely meet tomorrow. And I'll tell you when before tomorrow. Don't forget to check the posts of this channel so that we will know exactly when to meet. So this is the answer to this. It doesn't take time at all. I do hope it is well understood. Is it clear? Okay. Wow. Someone said, wow, that's precious stars. Okay. I think is yes, precious stars. You got it. You are correct. Okay. You are blushing, right? No problem. Okay. Now we move to the next phase. We move on to the next phase. We move on to this other phase. Now, there is another phase that I need to show you right now. Let me show you what. Okay, no, I don't think I'm going to show you here. Yeah, let me show you something. Look at this. Something like this. If we are giving y, y equals to tan x. What is dy dx? See? Find dy dx. This question is no more than 2 seconds. It's not more than this is no more than 2 seconds. Just within 2 seconds, you will get the answer. You don't need to solve anything here. Just go to that table. The table is like find dy dx when y is equal to cos whatever. So that's what it is. So dy dx, the solution to this one, I don't want to bore you wasting your time. I'm sure some of you already know the answer. So since y is equals to tan x, I just brought this, okay, for us to understand that it doesn't take time. dy dx is equals to, go to the integral table, you will see it there, right? What is it? It's sec square x. This is the solution, okay? This is the solution to this question. So it doesn't take, if I want to see this, just go to the option and look for sec square x. Don't waste time. Some person will change it to cosine over sine or sine over cosine and be doing quotient. Don't do that, oh, because the time is the challenge. You know it, but the time will not allow you to do it, okay? That's why we always want our students or viewers, yes, to understand the tricks, the shortcuts, the easiest method, the fastest method. So that's what we do here on AZ Science TV. So thank you very much. Now let me show you the method I wanted to show you before this one, or called differentiate this with respect to x. Okay, we are in okay, if, look at this, if y is equals to cos, just look at what I want to write to, cos square of x. Can you see this now? Find dy dx, or find the differential coefficient of this. You can see that this one now is squared. It's squared. It's not 2x. This is not 2x. This is cos square x. It means that cos x has been squared. Let me show you how it is. This one here, in fact, I will show you. You will see it now. You will be amazed, so that you understand what it means. This means y equals cos square x. Now, what this means is that cos x has been squared. Look at it. If I have cos x like this, it means I have squared cos x. So when I square cos x, I will arrive at cos square x. This is what it is. That's the meaning of this statement. So you are now going to use that method. You still remember that method, right? Good. That method I said initially, that you are going to start from here, solve what is inside. If you solve what is inside, what are you going to get? Then before you now differentiate, you just do the normal thing here. So we are going to do it now. Okay, I'll show you how to do it so that you don't waste time when you see something like this. Some persons will go and be using trigonometric identity. I've seen someone who used 1 minus sine square or whatever. You don't have to do that. Okay, or if you like, go ahead and do it, no problem. Look at this method. This one is the same as cos x then raised to power 2. This is another method, okay? But in JAMB, I'll just use the shortcut, bypass this one, but I'm just showing you this and this are the same. All right, so solve this one inside first. Cos to sine, what's going to be? It's going to be minus, right? Minus sine, minus sine x, right? Cos to sine is minus sine x. Am I right? Yes, sine x. Then close the bracket. Okay, then come here again. Now solve this one as if it is x squared. You see it now? Solve the whole bracket now as if it is x squared. You know, if y is equal to x squared, what is dy dx? Dy dx is 2x. Okay, so solve it as if it's 2x. And this becomes 2 cos x. 2 cos x. Then remember the 2 is outside. The 2 is outside. Then minus 1 from here. You just get 1 here, right? So what does it mean? It means we now have 2 cos x. So that is what we are going to get when you do this. Just like we have done before, previously. In our previous examples, you can see that this looks exactly like that. It's similar. Now the next phase is 2 and minus will combine, okay, using products, and that becomes minus 2 sine x cos x. You can call it sine x cos x. Sine x 2, this is 2 sine x cos x is negative, right? Yes, that's what it is, negative. But can we combine together? If you combine this together, look at it's 2 sine x cos x. This is the same thing as minus sine 2x. I know most JAMB will not leave it like this, so they will bring it like this. This is called double angle. This principle came from the principle of double angle. Look at how they got this one from here. How they got it is that, look at this general formula. They gave sine, okay, sine brackets a plus b is equals to, what it is this, is sine a cos b, sine a cos b, okay, then plus sine b cos a plus sine b cos a. This is what they use to get this one from here. You know, a and b are the same now, right? A and b are the same. So if a and b are both x and x, so which means this is sine 2x. When you add up, comes sine 2x, right? Forget the minus, okay? The minus came from differentiation. Then if this is a is x, this is x, this is x, and this is x, right? They are all xx, which means they are the same. All of them are the same, okay? They are the same. That's why you have 2. So this will be sine x cos x plus another sine x cos x. So sine x plus s, okay, sine x cos s plus sine x cos s is equals to 2 sine x cos x. And it's equals to sine 2x, sine 2x. So it is from here that this one came about. It's called double angles. We have double angles, we have multiple angles. Okay, but this is double angles, all right? So I hope it is well clear. This was how we got this. So I wish you all the best, excellence for all JAMB candidates. Okay, those of you that are going to write JAMB, you are going to do extremely well, all right? In fact, you'll be amazed after this exam. So I wish you all the best, but make sure you keep your head down and study hard. Then pray and do your normal work, and you see yourself flying high. So this is how we are going to finish this one. Then we'll go to the next phase. Let me show you this one, this particular one. Look at this one for if y is equals to, if y is equals to tan square x, then find dy dx. Yes, let's find dy dx. So what's dy dx from here? This is the same thing with the other one I just did now. Okay, there's nothing too difficult there. Nothing is difficult. Solution. Okay, so we have our y. Our y is equals to, oh, sorry, it's like my microphone. Okay, it's still on. I thought it's already off. So I wanted to change it. Let's. Obviously, it's still on. Okay, this is tan square x. Please, if it's off, let me know. Okay, if I'm not looking at the mic itself. So this is y. What will be my dy dx? What will be my dy dx? Solve it like normal, okay? Remember, this one is the same thing as tan x square. This is like this, okay? Like the one we did before. So differentiate what is inside here, okay? If you differentiate it, what do you get? You get sec, okay? Sec square x. And that's what we get when we differentiate inside. Don't forget, I just wrote it here, standard integral. Please learn standard integral. If you want to do well in trigonometric differentiation, you must learn standard integral. It's very, very important. Please don't forget it all. Before you go to exam hall, make sure you learn standard integrals. So this is for this. Then we will now go ahead and differentiate this one like x square. Like x square, like the way I said x square is. If we differentiate x square, what's dy dx of x square? We'll get 2x. That's what we'll do here. So let's differentiate. It gives us what? 2. So that gives us 2 here outside the bracket. Then we have tan x. Then minus 1 from here. Okay, minus 1, that becomes what? 1. That becomes 1. So finally, we'll have 2 tan x sec square x. Okay, if you don't want to do it like this, there is another way you can proceed. You can proceed. Let me show you what we are going to do here. This sec x in square. So remember that sec x is 1 over cos x. It's 1 over cos x. So this will be 2 times tan x is equals to sin x over cos x. Sin x over cos x. That's what it is. Tan x is sin x over cos x. Then times sec x is 1 over cos x. Okay, sec x is 1 over cos x. 1 over cos x is, listen, this one is correct. You may stop here. But sometimes they may follow this pattern. Okay, just to trouble you. 2 times sin x. Just know that this one is equal to this, please. Okay, it's under trigonometric identities. We did it yesterday. Okay, but those of us that were with us, I hope you got it well. All right. So this is already done. So we can multiply these two, right? Yes, we can multiply it to have about 2 sin x divided by cos square x. Cos square x. Okay, so it's like this. It can be like this, and it can be in any other form. Okay, so this is exactly what it is. Yes, 1 over, yes, it's correct. This is, so it can be in this form or this form, whichever form you see it in the exam. Okay, yes, maybe tomorrow or this evening. Some of us are writing this evening. So like this, 2 tan x sec square x, or 2 sin x divided by cos square x, or it can be 1 minus sin square x. Okay, yes, it can be 1 minus sin square x. It can be in any form. Okay, so whichever way you find it, don't worry, they are all correct. The option will definitely dictate the answer. In fact, from the option, you will know the right answer to take. All right, so this is where we are going to move on to the next stage now. Now, the next stage is called segment C. Yeah, okay, oh yes, we are in segment D now. Yes, we are past segment C. Segment D is called application. Some of us don't know the application of differentiation. We have been doing dy dx. Okay, but what is dy dx? Where do we apply them in real life? Yes, we are going to know here. There are several applications of dy dx, but in this class, in this segment, which is segment, yes, in this segment, we are going to learn how to apply dy dx. So let's proceed without wasting time. I do hope you are chatting me up. Please don't also forget to, and don't also, okay, thank you very much. Linus Paul, thank you. Emmy, yes, Emmy Spark, thank you very much. Linus Paul and Emmy's, yes. I also have Lekon, yes, Lekon Ogungbe, right? Yeah, where does the square on set square takes effect? Yes, what does it take effect? It takes effect in, God bless you. You know, that's why it's good to attend previous class, okay? Yes, you attend previous class. I do hope you have subscribed, because in the following class, we are still going to explain. This set square, let me show you where it came from, okay? This sec square, okay. Where does it take effect here, right? You are correct. Yes, where does it take effect? It's here. Sorry, I didn't put it right. Good. It's going to be here. Okay, it's going to be square. Okay, it's going to be square here. Sorry. So this, which means we are going to have raised power 3 right here. Okay, raised power 3. Yes. Thank God I watched you. I saw what you did there. You're going to be raised power 3. Because this square. Okay, because sec itself, sec theta is equals to 1 over cos theta. Okay, so if you square here, you are also going to square this one. All right, so that's what happened. I apologize for that. Okay, yes, that's what it is. I hope you have seen it. Yes, definitely the answer will tell us which one and which way to go. Now we go to what we call applications of differentiation. Yes, applications of differentiation. Differentiation can be applied in different form. In this class, we are going to know. So, welcome to the new segment now, which is the application of differentiation. Yes, let's call it application. Yes, applications of differentiation. So let's look at this question. So I'm going to make it, look for a snappy one, very short. One is gradient, okay? Part one is gradient. So we're going to look at gradient first. Yes, because this one is very, very popular. Yes, gradient. Please do well to watch the former one, the one we did on gradient or coordinate geometry on ordinary maths. Okay, this is gradient. So let's take some questions in gradient. Gradient also means what? Slope. Don't forget, gradient means, it means slope. That's what it means. Gradient also means what? Slope. Yes, how slopey is the land? So whenever you are doing, whatever you are doing, note the dy dx, or change in y divided by change in x, which is the slope of any land, any plane shape, or any plane surface, or any line, okay? Don't forget this, very, very important. So this is the first part we are going to deal with under the application of differentiation. So question one, the first question, find the slope of the curve. Find the slope. Find the slope of the curve. So a curve is always having a square or a cube, or even more. Okay? 5x minus 3 at these coordinates. Yes, you see? So coordinates, a point is coming now. This is a point, and the coordinates of the points are given. We have the x coordinates and the y coordinates. The first letter is x, and the second one is y. Okay? Please don't forget, this is very, very important. So please do well to subscribe, okay? So that you can keep following our class, because this is very important. If you subscribe, you keep following our class, because the next class will, this is the foundation for the next class. So it's good if you come over here, okay? You can see coordinate, you can see gradient. In our other class, I think we did gradient. Yes, right now we are doing gradient again, but this is different gradient. The other one we use y2 minus y1, x2 minus x1, but this one is just dy dx. That's why you should subscribe, so that you will keep getting more and more of our classes. Okay, so find the slope of the curve. This is the curve. So we are giving y to be x squared plus 5x minus 3. Now, slope is equals to what? Dy dx. Please don't forget, slope is equals to dy dx. This is very important here. Dy dx, that's change in y divided by what? Change in x. That is what slope is all about. Don't forget that, please. So, which means we have to find dy dx. Now, let me show you the trick here. Remember, they gave us 2 points, but we don't need the 2 points. Why? Because we are just going to substitute the value of x here. Okay, there, we know when you differentiate, there will be no y again. What you now have is dy dx, no longer y. So you neglect the y coordinates, and choose only the x coordinates. Don't forget, this is very important. So let's get the dy dx, which is the slope. So you're going to write here, slope, write slope equals to, slope equals to, this is it, slope equals to dy dx. Dy dx. So that's what it is. Slope dy dx is equals to what? Differentiate this now. I'm sure we are already used to differentiation. So if you differentiate x squared, we are going to get 2x. Then if we differentiate 5x, we are going to get 5. We'll get just 5. We have been able to differentiate. Is there y here? We don't have y here, right? So what is the slope? Just take the x value. This is x. Why this is y? Just take this, okay? Take this one and cancel this. We don't need the other one, okay? Just take only this, all right? So that's what we need. Take it at, okay, let's say, let's write it here, at 1, 4, okay, at 0.14, dy ds, dy ds is equal to 2, open bracket, 1, then plus 5 here. We can now go ahead and solve, right? Very easy. Easy peasy, right? 2 times 1. 2 times 1 is 2, then plus 5. And that gives 7. This is the answer to the question. This is how you are going to find it. Okay? There are different patterns, but normally this is the basic. Okay? This is the basic way it will appear. So please don't get it confused when you see something like this. It's very, very easy. So that is how question may come sometimes. Now I'm going to give another question. Let's look at this question. This of the points where the gradient is 0. Oh, okay, I think I made some errors. Now let's look at this one so that we don't waste our time. Any question? Yeah, if you have any question, just let us know, please. Let's know in the chat box. Let's know. Okay, please. There is no special place for chat. Just put hashtag. Then you can go ahead and let us have your say. Okay, yes, because the class is for all of us. It's not just for me. And in fact, there's nothing, I can't do anything here if you are not there. So you are there because you are here because, or I am here because you are there. So that's how we communicate. All right. AZ Science TV appreciates every one of you because you are super, super wonderful. So thank you. Now we move to the next phase. This is application of differentiation. Application of differentiation. Now let's look at the second one under gradient. Remember, we are still dealing with gradient. The slope of the tangent is okay. It's the same thing. Find the slope. At what point is the gradient of the curve equal to 0? Yes, look at this. At what point? At what point is the gradient of the curve? Is the gradient of, at what point is the gradient of the curve? What is the curve? X squared minus 6x plus 3 equal to, at what point is it equal to 0? That's the meaning. So at what point is the gradient of this function, of this expression, equals to 0? I'm sure it is clear, right? Yes. Once you hear the word gradient, fix your mind as dy dx. Okay? Yes, fix your mind as dy dx. So we are going to solve this now. We have x squared. We are given x squared minus 6x plus 3. Yes, I'm going to show you something. It means that y, please don't forget, it means that y is equals to this. That's the meaning. But before I continue, I want to show you something. Okay, let me show you something very important here. Okay, gradient is actually dy dx. Now, we are looking for points. Please take note of this statement. Always mark all these ones. But don't do that in JAMB, okay? There's no need to be marking all the questions. But take note of this. At what point? So we are looking for the point, which means we are looking for P, for instance, X and Y. This is what we are looking for. This is exactly what we are looking for. So how do we find x and how do we find y? Let me tell us the trick. You are going to differentiate this. When you differentiate this, equate it to 0, equal to 0. So the differential of this one equal to 0. That will help us to find x. And when we find x, go back to this original equation or expression, substitute for x, then we'll get y. So that is how to get x and y. You must get the two because they said at what point. So you need x and y. If we don't get x and y, we cannot get the point. Is that taken? So we will proceed now to get it. First, let's get our dy dx, which is the language of gradient. So differentiate x squared, we are going to get 2x. This is minus. It remains there. Nothing takes it away from here. Okay. Then differentiate 6x. We'll be left only 6. Here is 2 and here is 6. This is it. Then we are told that this slope or gradient, what you call gradient, what we call gradient, gradient which is dy dx, okay, gradient which is dy dx is this. We are told that it's 0, so equate it to what? 0, so that we can find the value of x. So transfer this one here minus 6 to this side. That gives what? 2x equals to what? 6. So when we do that, once we have achieved this, we can divide by 2 on each side. So divide by 2 on each side. These 2, we cancel this. So we have our x to be equals to 3, which means that this x, the value of x is 3. We are looking for the point P. So we have gotten the x coordinates of point P. Now we want to go and find the y coordinates from here. Okay? By substitution, we can substitute now. We already know that y is equals to x. So let's substitute directly here. Y equals s squared minus 6x plus 3. I'm just showing you, but in the exam, in JAMB, you don't need to do that, okay? Just substitute directly. So this gives 3 squared minus 6 open brackets 3, then plus this last 3. That is what we'll get here. Okay? So what is 3 squared? Yes, what is 3 squared? 3 squared is 3 times 3, and that is 9. Minus 6 times 3 is what? 18. Then plus 3. So if you add this 3 and this, remember this is positive and positive, right? It's like 9 plus this 3, then minus 18. You are collecting like terms in terms of positivity, but this is plus. So 9 plus 3 is what? Is 12. Then minus 18. So what is 12 minus 18? Is simply minus 6. Minus 6. Okay? So we have gotten our y. I'm supposed to be writing y. Please, this is y. Okay? Just write y equals to. So y is minus 6. Yx is what? Is 3. This is x. X is 3 here. You can see it from here. Then y is minus 6. So we can now write our point P as what? 3 for x, and for y we have minus 6. This is how to do it. What you do first, differentiate and equate it to what is given. 0 is given here. So it may not be 0, okay, it can be something else. So differentiate it and equate it to that number. Then find the value of x. Once you get the value of x, it can be 3 or anything, depending on the given expression or function. Then go to the original expression, not the differentiated one. In fact, there is nothing like y here. So you have to come here to get this y. Substitute 3. Substitute for the value of x here. We got 3 here. So we substitute for 3. 3 squared is 9 minus 6 times 3, which is 18, then plus 3. So that was how we got everything here. It's that very simple. It's not difficult. Okay, don't be afraid of calculus. Calculus is not a big deal. All right? Come on. Calculus is not a big deal. Something light. So, and I know you like something light. So calculus is one of those things. That's why we shouldn't be worried at all. So if you have anything to say or any chat, why not go ahead? Let me see. I want to know your position. Okay, do you have a question, suggestion, anything? Don't just forget to leave a like. Okay, then do well to subscribe and turn on notification, especially subscription and notification, because the next class will be built on this class, and it's not good to missing the previous class. All right, please don't miss previous classes. Turn on notification, then subscribe and turn on notification so that YouTube will always notify you whenever we are coming online. Okay, yes, the slope is 7. The slope, is it 7? Somebody said slope is 7. Is that correct? Anna, please check now. Can slope be 7? 12, 18 minus 12 is 6. So 18 minus 12. Or did I get anything wrong? This is 12. Oh. This 2 is 12. Okay? Yes. 18 minus 12. Please, let's check now. 8 minus 2 is not 6, and it's 0. Right? Although you have tried, you made an attempt. Okay, Anna, thank you very much. I appreciate you for making an attempt too. Okay? Yes, this is the slope. It's the slope. Okay, slope. No, this is y. This is not slope. This is y. Are we taught to find this slope? No, now we are not taught to find slope here. So I'm sure it was the previous example that we are talking about. Yes, I think we got something like that before. So thank you. We move on to the next phase. So we are not going to waste time now. Now we are done with slope. These are the ways that question can be set within slope. We don't want to waste time. Okay. Now the next phase is called the stationary point. I will explain that vividly. Please, you have to stay and watch this part. It's very important because this is critical. Because if you don't know stationary point, it's a very popular area that JAMB loves setting. Yes, using it to trick students. Okay. Now we are looking at not stationary point. We are looking at turning points. This is turning points. Now this is gone already, right? Turning point. Yes, turning point. What is turning point? What is turning at that point? We call it turning point. Yes. Turning point. Okay, I'm going to do it like this. There's something here. Okay, turning point. Yes. What are these turning points? Look at a curve here, something like this. Here is a point, and here is a point. All right. These are turning points. A turning point is the point where the curve changes direction totally. Okay, where it curves back totally from where it's coming from. Okay, the curve was initially going this way, but finally changed direction and started coming down. It was going up this way, but from here it started coming down. So that point where it changes direction totally is called the turning point. Don't forget. Then the turning points are of two types. Please, we have the maximum, and here we have the minimum point. So there are 2 points here. We have the maximum point and the minimum point. At every turning point, there is no change in y. Okay, there is no change in y at every what? Turning point. So there's no change in y. That is why dy dx at every turning point is equal to what? 0. I want you to be following this because the next questions will come from here now. The next questions that will simplify any question at all will come from here. Okay? So at Okay. Oh, the audio is off. Oh, sorry for that. Okay. The audio is on now. Can you hear me now? Please let me know in the chat box. Can you hear me? Precious Stars. Yes, the star of today. Can you hear me? Precious Star told him that the audio is off. Yes, now I have already put on the audio. I do hope you can hear me, Precious Stars. All right? Can you let me know? Okay. So I think it's on now. You can now hear me back. So we are going to look at this. Remember, at every turning point, dy dx is equals to 0. Look at it. That's what we have here. It's 0, which means we are going to differentiate first. What is the function? The function is y equals to x squared minus 2x minus 3. Please, you are watching, you are not subscribed. No, now, come on. Do well to subscribe, okay? So that in our next class, you will get bumper package, okay? We will lay more foundation. From this, we'll move to the other aspect of calculus. Then we'll grind everything concerning the applications and the rest, okay? But this is only possible if you subscribe. Or your subscription is what will make you join us, because if you turn on notification, not waste any of the time, okay, and you'll be with us. So thank you very much for subscribing. Just smash the button, that subscribe button, then turn on notification so that YouTube will notify you in our next class. So don't forget, x squared is what we have here. We have to differentiate. When we differentiate it, equate it to 0. Look at it here. Remember ingredients. dy dx can be 0, 1, 2, 4, 5, 6, 8, 9, 10, or anything. But in turning points, maximum or minimum, dy dx must be 0 because there's no change in y. So dy dx must be 0. Then it means dy dx is 2x. If you differentiate x squared, you get 2x, right? Yes, that's what we'll get. Then here you have minus 2. And when you are done, equate it to 0. At minimum, you write at minimum. At minimum points. As turning points. But in this case is minimum. Don't forget. So dy dx will be 0. And this is dy dx, and we have gotten it, and it's equal to 0. Look at it here. At minimum or maximum points. So we proceed. Transfer this one this way. If you do that, we'll now be left with 2x alone equals to what? 2. Because this minus 2 goes this way, becomes plus 2. Then we can go ahead and do what? Simply divide. If we divide, we'll be left with only x equals to 1. This is the value of x. Please pay attention to this. So please, I want you to take note of this so that you don't go doing something else. All right? This is at what value of x? They didn't say find the coordinates. They didn't say at what value of y. Some persons will go and look for value of y. And the value of y here is 1 minus 2, which is minus 1. 1 minus 2 is minus 1. The minus 1 minus 3 is minus 4, right? So some people will go and write, you will find minus 4 in the option. That's one of the options. Some persons will choose that because it's value of, okay? But here, this is the only answer we are told to find. Look at it, value of x. Once you get it, you are done. So move on to the next question. After shading, after clicking this answer, right? We no longer shade, it's now computer based. So thank you very much for watching. Please subscribe, okay? Subscribe if you haven't. Some of us are just joining. Then the likes are 10. I want the likes to increase, okay? To 15, 20, and 25, okay? We want more likes. Yes, that will make YouTube to be pushing it to more JAMB students. Okay, a lot of students are looking for classes, but most of the classes are paid ones, but they are looking for free ones. Please share it. Okay, if you have anybody that is writing JAMB, just share it, please. So let's proceed to the next question. Note dy dx equal to 0 at maximum or minimum points. So quickly go to the next one so we don't waste time at all. There's no time to waste. Yes, this is a hot season, okay, a very hot season. JAMB is hot. Find Yes, if this is it, find the value of x. Look at it. If the question is coming with if now, if y is equals to 3x square minus 2x, then plus 1. Find the value of x. It's the same thing, yeah. Find the value of x. Okay. Find the value of x when dy dx is equals to what? 0. You can see this. Anytime you see dy dx equal to 0, it means it's turning point. Yes. So that's exactly what it is. It means it's the turning point. Now we are going to do it like we did the first one. So who can help us out here? Who has the answer to this, the solution to this? We are already given y to be equals to 3x squared minus 2x plus 1. We have to find the value of x. In fact, this is a repetition of the first one. They just change things here. That's how JAMB behaves, okay? They keep changing. They change. JAMB does not change everything, but the pattern remains the same. You can only adjust some of the figures, but the pattern remains the same. Okay? The pattern is the same. So that's why we advise students to always study JAMB patterns. Study, as you are studying the question, study the patterns. All right? So who can tell us the answer to this? Let's see the answer in the chat box. Yes, I want to check the chat box. Let's be sure. Who has the answer to this now? Who has the answer? Please do well to make an attempt, okay? It's very good that you make an attempt. It helps a lot, especially for learning, okay? It helps a lot. So let's know who is chatting us. Who is the next? Yes. Okay, Godfrey Sunday. Fame. Yes, you said hello. Thank you very much, Godfrey Sunday. You were with us last time. Yes. Thank God. Onye Gulem. Okay, thank God. Onye Gulem. Thank you very much. I appreciate you. Anastasia. Yeah, yes. Anastasia. Thank you, Anastasia. I appreciate you. Then Precious Stars. Okay. Oh, thank you very much. I appreciate all of you. AZ Science TV is very grateful for having all of you here. Okay. Then let's go this way. We are going to find dy dx. Look at the question. Look at this one here. Just look at this. So which means you will find dy dx of this expression. Okay, find dy dx of this expression, then equal to 0. That is what the question is all about. Okay, so let's find dy dx first. If you don't find dy dx, you cannot equate it to 0. But this expression is not equal to 0. It is the dy dx that is equal to 0. So differentiate this. This here becomes 3.2. Let these 2 come here and multiply these 3. Then x. Then subtract 1 from these 2. Becomes 1 here. Then minus 2. X will disappear. Okay, when differentiated, x will disappear, leaving only minus 2 here. Leaving only minus 2. 1 is already gone. When you differentiate a constant like 1, 2, 3, 4, 1,000, 1 million, it will just disappear. So what does it mean? It means 3 times 2 is 6x. X raised to power 1 is something as x minus 2. Okay, and this is equal to what? 0. Look at it here. 0. Look at it here. Can you see it? So equal to 0. Then the next phase is to take this one right here. This minus 2, we cross it to the other side. What do we have left here? We are left with only 6x equals to 2. Equals to 2. Okay, this is minus 2. When it is crossing, it changes to plus 2. Then we can divide by 6 on each side. We divide by 6 on each side. So 6 we cancel 6. All right, 6 we cancel 6. We will now be left with x is equals to 2 here is 1. And 2 into 6 is 3. This is the value of x. Please, value of x. Don't forget, you must understand what we are looking for, or else we may be confused. All right, so we need to understand what we are looking for. We are looking for value, the value of x. The value of x when dy dx is equals to 0. So that is the answer. That is the solution to this question.
Yes, thank you very much for joining. Please do well to like, share. Let the whole world start receiving this. Let everybody start receiving it, especially those that are writing JAMB. They need to get to this, okay? If they don't get it, they might be struggling. So please do well to help others, okay? Anywhere they are, just let them know that AZ Science TV is currently presently live. So let's go to the next question.
So this is same thing. We are still dealing with turning points, maximum and minimum points. I do hope we are taking down some of these things. And please do well to take it down, okay, with your pen and papers. So thank you so much. Okay, Precious Stars, thank you. Godfrey, thank you. And a whole lot of others. Okay, I'll keep appreciating every one of you, because your presence there is what is making the channel moving forward.
So let's look at this. Find the value of x for which the function is, okay. Yes, look at this. If the maximum value of y,
very good. Look at this. This is a typical JAMB pattern. If the maximum value of x, if the maximum value of, not x is y, yes, if the maximum value of y equals to 1 plus hx minus 3s squared is 13. If the maximum value of y, please not x, okay, is 13, find h.
yes, I know. How does this affect us?
Look at it. The maximum value, this maximum value of this expression is 13. Okay, but at that maximum value, something must be 0, right? Well, that's why it's maximum or minimum. But there's no change. I don't know if you understand. There's no change. We are not saying there's no value there. There is a value. Okay, if you have something like this, and you have a maximum value here. This point, for instance, is the maximum value. There is a value for x and y. For y here and x here, there are values, there's a value for it. But there is no change in that value. It's a constant value. That's what we are saying. Okay, it's just at that point. There's no change. That's what we are saying. We're not saying that that the value is 0. This one here, dy dx means change. The ratio of the changes. It does not exist there. Please, I want you to note that so that you don't get it confused. Because they are bringing 13 now. So they will say, but they said the value is 0 now. Why is it 13? Please, don't get it confused, okay? X is not 0, y is not 0. X may be 0, y may be 0. Okay, but not always. Please take note of this. So let's proceed. We have y. We are giving y equals 1 plus hx minus 3x squared, right? Good. Now we are going to find dy dx and equate it to 0. To enable us substitute for, get the value for x and substitute for x, and this is y. So substitute for two things. We are going to find the value for x, okay, and place it where we finally got x here. Then this 13 will now be placed in place of y, okay? Yes, we'll come back here and place y here and x here, and that gives us our answers. So let's proceed. Don't forget, h is an integer. It's a number. H is a number. So what is dy dx? Let's go. Dy dx equals to, differentiate 1 is 0. Then if you differentiate hx, h is a number, so h will remain there. X will disappear. Then minus. Differentiate this becomes 3 times 2, which is 6. That becomes 6.
Then we have our x here. Subtract 1, decrease 2 by 1. Okay, that gives us 1, right? Which is not necessary, so we can let it go. And this is equals to 0. Look at it here. That is the gradient. That is the turning point, sorry. Okay, that's the turning point. Which means there's no gradient. Okay, yeah, this is dy dx equals to 0. At turning points, there's no dy dx, there's no gradient. Do you get it now? That's the implication. So we proceed. Don't forget what we're about to do now. We are to substitute for here we have h minus 6x equals to this. So let's transfer this way, right? Yes, so transfer minus 6x the other way. We are going to have h equals to, yes, transfer. What do we get? 6x. H is equals to 6x. So wherever you find h here, put 6x. If you find h, put 6x. Then when you find y, put 13. Do you get it now? That's the easiest way to do it. Put 13. Although we are looking for, we are looking for h, right? So, okay, we are going to look for h. Since we are looking for h, let's substitute for h here. What is h? H is 6x. Yes, what is x? Let's substitute for x. It means our x is going to be h divided by what? 6. Replace. The reason for that is because we are not finding the value of x, but we are looking for the value of h. Please don't forget, find h. So let's proceed. Let's find the value now for h. Put this one here and put this one here. So let's proceed. Y is 13. So I'm going to write 13. Since y is 13, this is 1 here equals to 1 plus. This is plus. This is h. Okay, our h remains h here, right? Yes. Then dot x. This is x. X is h over 6. That's h over 6. Okay. Once we are done with this, we move to minus 3x squared. What is x? X is h over 6. That is h over 6. We'll square h over 6. This is what we're going to do. You can see it, right? So 13. We are going to have 13 minus 1. Sorry for the marker. It's like it's getting fainter. It's getting okay. Sorry, give me a few seconds. Okay, here we now have 13. Okay, minus 1. This one, bring it here, it becomes 13 minus 1 plus h squared, right? We have h squared divided by 6. That's what we have here. H times h is h squared. Then here we have minus 3. This is h squared. Don't forget, h squared divided by 6 times 6 is 36. Don't forget that this square here is affecting both h and 6. So, and this gives us 36. So we can use this 3 to reduce this. That gives 13 minus 1. Sorry, this is going to be equal to 13 minus 1 is what? Is 12 right here. Equals to, this is h squared divided by 6. The rest is simplification, okay? Once you get there, you get your answer. Direct. There's no problem at all. Okay? This is h squared, then divided by 6 minus 3. Can divide this, right? That gives h squared divided by 12. Alright? So we can find LCM. What's the LCM of this? Without wasting time, we have h squared here, right? And some students will use LCM. Okay, let's use what students we use. This is h squared, 2h squared minus h squared divided by 12. I'm sure we know why, right? 2h squared minus h squared divided by 12. So we can bring this one here, cross multiply. Just bring this one. I prefer starting with 2h squared. What's 2h squared minus h squared? Let's quickly do that. Yes, who has gotten the answer? Who can get us the answer? The h here. You see that it's very easy now, right? 2h squared minus h squared. Then this is this, right? So what's the answer from here? You can just tell us the answer from here. It does not take time at all. Never. Look at it. We already know the answer. In fact, the answer is there. So just tell us the answer. Let's see. So who will help us? Yes. Who is our helper today? Just tell us the answer. Yes. Precious Stars did it last time. My other viewers also did it. I do hope that you got it right. Please, but today is JAMB. Yes, I know. I know that today is JAMB. Okay. But some persons have not written. Please, question. Okay, do you have a question? Neba Carlos. Yes. Let me hear from you now. Okay. Your questions. Yes. Do you have any question? Let me see it. Put it in the chat box. If you have any question, please put it in the chat box. So let's proceed. I want to finish up this since we have gotten what we are looking for. In fact, it's in the answer there. So let's look at this particular point here. And this is 2h squared. Let me just write it the way it is there. 2h squared minus a squared. But don't do it in JAMB. Don't do this in JAMB, okay? This is 12 times 12 because time is running. So what is 2h squared minus a squared is actually h squared. And it's equals to 144. Now what is h? H is the square root of 144, which means h is 12. So this is the solution to the question. All right, h is 12. So this is the value we are looking for, h, not x. So we cannot use x. We have to replace x with h. That gives us the answer. All right, it doesn't take much time. Okay, don't forget to always use shortcut tricks. Sometimes they appear longer, but if you know exactly how to spot the answers, you will get it straight away. From here, you are done. From here, the answer is 12. 12 times 12. Okay, this is h squared. So this is 12 times 12. So the answer is 12. Okay, because 12 times 12 is 12 squared. Then here we have h squared. So the square will cancel the square. Do you get it? And giving us h as the answer. So this is how to solve this kind of question. Any other thing? This is maximum and minimum points. Maximum and minimum points. So any question, please, let's find out. Let's find out. If you have any question, just let us know. Yes, any question? So if there's no question, we move to the other segment, which is rate of change. There's what we call rate of change. Okay, rate of change. Yes, someone wanted to ask a question. I'm still waiting for your question. Please. It's equal to 12. Yes, someone has got the answer. That is Katin Anna. Oh, scholars. Then Lekon Ogungbe. Okay, Ogungbe, please forgive me if I didn't pronounce your name very well. Lekon Ogungbe. H equals 12. Yes, I have Lekon Ogungbe. You got it. Then Katin Anna, right? You got it too. Okay. Yes, somebody is saying JAMB is today. I know. JAMB is for 10 days, please. JAMB ends on the 25th or so. Okay, JAMB ends on 25th. If you count it, it's 10 days. It's just 10 days. Don't worry, some people are still writing, even this evening, tomorrow morning, and so on. People are writing JAMB. So we keep learning and learning. Okay, when it's your turn, you go and write. Okay, and I wish all of you success as you write. You will definitely be successful. Okay, thank you very much. There is no going back. We are all moving forward. So we are going to let this go right now. All of you got it. You got the answers. Those of you that gave the answers, you got the answers. So AZ is very happy, and the team, we are all happy here because you are getting everything we are dishing out. Okay, so thank you very much. Now the next phase is called rate of change. Rate of change. Yes, it's called the rate of change. It's differentiation. I'm sure you have seen. Okay, let me just write it first. Rate of change. Yes, rate of change. This is what. This is the next phase. I'm sure you know this. Yes, someone will say, I know the rate of change. Oh, change in distance over time is the rate of change. Change in volume over time. It's a rate of change. You know, so these are all rates of change. How does differentiation applies to rate of change? Okay, application of differentiation under rate of change. So let's proceed. We are going to look at the ones we have right now. Rate of change. So let's look at this question. Question 1 under rate of change. Find the rate of change of the volume. Just look at this one. Find the rate of change. But this is a direct question. Any student will just spot out the answer. Find the rate of change of the volume. Of the volume. Of the volume V of a sphere. Of a sphere. Of a sphere with respect to its radius. This is direct. With respect to its radius. With respect to its radius. So this is the question. So this is the question. With respect, find the rate of change of the volume V of a sphere with respect to its radius. What are the things we need to note here? Look at it. Where there is a change in volume and with respect to what? To its radius. That is dV dr. dV dr. Volume is V and radius, okay, with respect to its radius R, when R is equal to 1. Just look at it. This is how it is. So this is the simple way the question presents itself to us. All examination bodies can present this to us. What do we do first? Yes, this is the major thing. Look at this. This is a sphere. What is the volume of a sphere? The volume of a sphere, just like you write Y, this one will be V. Remember, we are looking for dV, d what? dr. That's what we're looking for, dV, dr. That's rate of change. And this rate of change is with respect to the radius R. Okay, is dV, change of the volume, dV, with respect to its radius, dr. That is what we are doing. Okay, so when we know our V, you must go and learn volume of solid shapes or plane shapes. Volume of plane shape, like what is the formula for the volume of a sphere? You must know it. Hemisphere. Hemisphere is half of a sphere. So for a sphere, the volume is 4 pi r3. This is the volume of a, okay, 4 pi 3 over, yes, over 3. We are correct, yes. 4 pi 3 over 3. This is the formula for the volume of a sphere. If it's hemisphere, divide this one by half. It will not be 2. The formulas are the same, but here will not be 2. 2 over 3 pi r3 for hemisphere. You can try that of hemisphere. Remember, we are told that r is equal to 1. But this is what we have to do. What's our dV? dV dr. So let's get dV dr. dV dr is equal to 4 divided by this 3. Okay, dot. Bring this 3 down. Remember, we are differentiating r. Okay, this is a constant, so you don't trouble this one. This one remains as pi, then dot this 3. Okay, that's 3 here. Can you see that? Then once you are done, what's r? Decrease this one by 1, that becomes r squared. Can you see it now? Then this gives us these 3. Okay, let me write it bigger so that you understand. These 3 will cancel these 3. Then this becomes 4 pi r squared. dv dr is 4 pi r squared. But we are not there yet. I want to ask you a question. Do you know that this is the area, this is the surface area of a sphere? The total surface area of a sphere is 4 pi r squared, which means this is the volume and this is the area. Can you see it now? So you can easily get them. Okay, if you can't recall them, just use this method and you get differentiate the volume of a sphere. You will get the area of a sphere. Now we are given that r is equals to 1. Look at it here. We are given that r is equals to 1. Let me clean this one to avoid confusion. Okay, we are given that r is equals to 1. So when r is equals to 1, when r is equals to 1, what is dv dr? dv dr is equals to what? Substitute, just substitute here. That's all. Okay, that's 4 pi times 1. Okay, r is 1, so 1 square. 1 square. So what does it give us? We have 4 pi. And 4 pi times 1, which is equals to 4 pi. That's how simple it is. This is called rate of change. So you will find something like this in the answer, and that is what you should choose. When the value is given like this, okay, when r is equals to 1, then the rate of change of volume V of a sphere with respect to its radius r, okay, will be this. So just differentiate, then substitute. Differentiate and substitute. That is how to get the simple answer. Okay, it is very easy. So if you have anything to say concerning this, let us know, please. Okay, if you have anything to say, let us know. And if you are not subscribed, please smash the subscribe button. Okay, I'm seeing a lot of viewers, but the subscription is very, very low. Please, I do hope you have subscribed. Smash the subscribe button if you haven't. It's very important, please, because this will help YouTube. We'll be pushing our videos. If you like, share, and do other things, okay? Then also engage us. Say whatever you want to, okay? As long as it's within YouTube policies, we are ready to take it. Do you understand? So if you have any contribution here or anything you have to add, or if you want us to subtract anything, no problem. What we are looking for is shortcuts. Anything that we can remove so that we'll get there on time. Why are we not going to take it? We'll take it because time is of essence to us. So if you have any question, let us know. Any suggestion do you have? Let's know. H equals to 12. Okay, that's where we ended. Message retracted. I don't know. Please don't say things that will put us into trouble, okay? So message can be retracted. I'm sure. I don't know who retracted the message, but please, okay, let's not put ourselves into trouble. Community guideline is very important here in YouTube so that we don't have ourselves put into trouble. Okay, so thank you, and thank you so much. Let me quickly put on the fans. So we'll go to the next one without wasting time. Okay, let's look at this present one. Remember, it is change, rate of change, rate of change. So look at this. If the volume of a hemisphere is increasing at a steady rate of this, at what rate is the radius changing? When it is 6 meters. Okay, we have that. Look at this. If the volume of a hemisphere is increasing, that's changing, okay? It's increasing at a steady rate, at a steady rate of 10 pi meter cube, yes. Then per second. Please don't forget it's time per second. At what rate is at what rate is its radius? At what rate is its radius? Please bear with me. The question is kind of long, but not too long. We're almost done. At what rate is its radius changing? Changing when it is, this is the last line, okay? When it is 6 meters. When it is 6 meter, okay, at what rate is the radius changing when it is 6 meters? Or 6 meter cubed. I'll check. Let's see. Now let's look at the simple way to handle this. So who can provide the answer to this? Yes. This is a very simple question that we can solve in a matter of minutes. Yeah, just seconds or so, not minutes. Because so what we are going to do, we have volume here. Please always remember, we have volume right now. This is hemisphere, not a sphere. So it's half of what we did. Okay? So, and the steady rates. Don't forget, this is rates. The rate of change is in per seconds. This is not dv dr. This is dv. This is dv dt. This is dv dt. Sorry for the noise, please. I'm inside a park now, please. This is dv dt. Okay, this is dv dt. Look at it, volume per second. Okay, volume per time. That's dv dt. Then don't also forget that we have dv, we have dv dr. Then what are we looking for? We are looking for if the volume of a hemisphere is increasing at a steady rate. So how do we solve this kind of question, right? So what is the volume of a hemisphere? Very, very good. So volume of a hemisphere is what? Half of the volume of a sphere. So what is that? Half of the volume of a sphere. So for the hemisphere is 2 over what? 2 over 3, right? 2 over 3 pi r3. This is the formula for the volume of a hemisphere. Remember, for a sphere to be 4. Therefore, a hemisphere, it is 2. Or it has been divided by 2. Don't forget. Now, find dv dt. Find dv dr here. What's dv dr? This is dv dt. This is dv dr. Okay, don't forget. This is dv dr. So, dv dr will give us 2 dot this 3. Okay, then dot the pi, then r square. Because you are going to remove 1 from here. Transfer this 3 down here. Then divided by 3. Don't forget. So this 3 will cancel this 3. We will now be left with what? 2 pi square, right? Yes, that's 2 pi r. Sorry, 2 pi r square. Yes, 2 pi r square. That's what we're going to have because the 3 has cancelled this 3. So we are now left 2 pi r square. This one now is the rate of change. There is 6. Okay, we are going to replace here with 6. What do we do here? What is dv dr? We are giving 6 here for r. So that gives 2 pi times 6 square. Okay, 6 square is 36, then times 2. That's 72 pi. Do you get it now? So if you substitute this 6 here, you have 72 pi. Because 6 times 6 is 36, times 2 is 72 pi. Okay, 72 pi. So that is dv dr. What are we looking for? We are looking for the rate of increase. So this is what we are looking for. Let me show you. so that we'll understand better. Okay, let me show you here, right here. Because of space, we usually have space issue when we use vertical orientation. Please bear with us. Okay, so in this case we have dv. Don't forget, you are starting with dv dt. dv dt is equals to dv dr dot dv dr dot dr dt. Look at it, radius changing, radius changing. Look at radius changing. We know this already, right? This one, what is it? Look at it here. Can you see it now? This one, 10 pi m raised by 3. Okay, that's m. That is this one, dv dt, because it's volume per time. Change in volume per time. You get it now? Then dv dr is this. Can you see it now? dv dr. Look at it. So dv dr is equals to 72 pi. And dv dt is equals to 10 what? 10 pi. 10 pi. Okay, in their various units, they have different units. Now we are looking for this one here. Look at this one we are looking for. Radius changing. So let's quickly find it without wasting much of our time. Okay, we have gotten what we are looking for here. What we have to substitute. So we clean this place so I don't waste our time. So this is now dv dt is 10 pi. So write 10 pi here. 10 pi equals to dv dr. dv dr is 72. 72 pi. Then times dr dt. You see that now? So we are going to divide, just crush them and forget. Okay, don't waste your time. Which means we have dr dt will now be divided by this. Okay, it becomes 10 divided by 72. 10 divided by what? 72. So we can reduce to the lowest term to get our final answer, right? So 2 here is 5 and 2 here is 36. Okay, it's 36. Is that taken? So this is what we have, and it's in centimeters, right? No, it's in meters. I think, yeah, it's in meters per second. Yes, meters per second. This is what we have as the answer. You can go ahead and do what? And change to decimal. All right? You can go ahead and get the decimal point, but it's not necessary. Okay, so this is how we end the class for today. Thank you, and thank you so much. I appreciate every one of you, your contributions. I am so grateful for everything, for staying with me from the beginning of the class till now. So AZ Science TV appreciates all of you. Okay, I can't mention all your names because you are just too wonderful people, and you are such powerful audience. I appreciate you a lot. For those that have enrolled for JAMB, thank you. You are going to succeed. Okay, so I appreciate you for enrolling for JAMB and staying with us. Also, we are very grateful, and we know that at the end of the day, you will come out successful. So nothing will stop you from being successful. This period will mark the end of attempts to write JAMB. So this time, we are aiming high. So don't forget to join us tomorrow. We are going to be live again tomorrow. Do well to check the community post because I'm going to post the time for tomorrow's class. So thank you very much. For now, have a very wonderful moment and goodbye for now.
Yeah.